Right, year 11s. I got about 2 hours before I got to rush off to my dinner with my parents. But I'm going to try to make this video as the last video for year 11. So that means I would upload a total of 3 videos for our missing 4 sessions. I think that's more than enough to keep you guys working until I come back. And you know, I don't want to do too many videos as well, not only because I'm busy, but I don't want to do too many videos in the sense that I'll come back and you guys are still struggling with 2C, and it's a lot of information beforehand. So I'm going to make these 3, and if you already finished off 2E by the Wednesday, probably means you'll find 2F is pretty easy as well. And I'm not sure if you actually have a lesson on Wednesday because it's session 5 and 6. I'm not sure if that's scheduled. So do check on the day on a Wednesday. But I'm going to do 2E, and then I'm going to make one last video for my year 12s as well. And that will conclude for today. So thank you for watching the videos. This should be for the Wednesday session. So Monday should have been 2C, Tuesday should be in 2D, and Wednesday should be 2E. But obviously if you've gone ahead, then good work for you. Yeah, good work on you. All right, here we go. Exercise 2E now. So we've done some straight line equations. We've looked at distance. I'll just revise it again. So exercise 1A was it 2A? Oh, sorry, 2A was distance and midpoint formulas. Okay. We had exercise 2B, gradients. The only new thing in gradients, remember, was the tan theta is equivalent to your gradient. And the hardest one is when you have to work with negative gradients, where once you find out theta, you have to remember to take 180 minus that angle. Yeah, so that was the hardest one there for 2B. And then you went to exercise 2C, which I uploaded a few hours ago. 2C was about finding the equation of a straight line. So equation of a straight line. Okay, straight line. That basically tells you, you'll be using 2B, find M, find C. You might have the 2 coordinates to find M. You might have the y-intercept and a coordinate, find M, that kind of thing. So you're finding the equation of a straight line. So just remind you, y equals mx plus c. And then 2D, I did the video on this, which is sketching the equation of a straight line. And I showed you the axis intercepts, so x-intercept and the y-intercept method. Okay. And now, once you know the x-intercept, y-intercept method, there's parallel lines and perpendicular lines, things to focus. Just to add on 2D, most students will forget the horizontal line and the vertical line. Okay, remember vertical line is for x equals to whatever the number is, so like x equals 3, so it'll look like this, x equals 3, and for horizontal line you'd have something like, I don't know, let's say y equals 2, then it crosses at 2. Okay, just quickly revise what you should have learnt by now on a Wednesday. Okay, sorry, again, that's my phone. And okay, all good. Let's go through some of the questions here. So parallel and perpendicular lines. Now, we know that parallel lines, parallel means that you have the same gradient. So, for example, if you look at this example here, y equals 2x plus 3 and y equals 2x minus 4, they both have the same steepness. That's what the gradient means, right? Same steepness. So it means 2 over 1, because that writing 2 as a fraction is 2 over 1. And 2 out of 1 just means that you're going up by 2. So every time you climb up 2, you walk across 1. Yeah, so across 1. That's what it means. So they both have the same sort of ratio and steps. That's why they're parallel. They, like one's not steeper than the other, both the same steepness. The only difference is one says plus 3, which we now know from last exercise or 2 exercises. We know C represents the y-intercept. So this one crosses at 3. This one should cross at negative 4. That's the difference. They are 7 units apart from each other. There's 1, 2, 3, 4, 5, 6, 7. There's 7 units apart from one another. Okay, that's what the y-intercept does. It just shifts the graph up or down, but it's the same steepness. So basically, if I took this line and I minus 7, it'll bring it back down here. Okay, so it'll go down there. All right, so that's what the parallel means. It's the same steepness, just a different gradient. I mean, different y-intercept. Okay, so two non-vertical lines. So if it's not vertical, then they are parallel if they have the same gradient. So that's what I showed, same gradient. And two non-vertical lines with the same gradient are parallel. Don't worry about that. That means exactly the same thing. The only difference is that they have different y-intercept. Okay. Perpendicular lines, on the other hand, is when perpendicular means when you are 90 degrees with one another. So when you draw it and you have this 90-degree cut, so it's kind of like an L shape of a square or rectangle. This is perpendicular. Okay, so they cross one another at a 90-degree angle. That's what perpendicular means. Now, one of the properties that you learned back in year 9, which I would have proven it to you if I had you in year 9, that the gradient, if you multiply the two gradients, it will equal to -1. Okay, so what I'm saying here is if the first gradient was y equals 2x, then for it to have a 90-degree cut, so the second line, so let's say this line here or this line here, okay, what it has to do for it to have a 90-degree, which I'll do another color so you can see, for it to have a 90-degree angle, this equation here has to have a gradient, okay, m. The gradient has to be something that when you multiply it to this gradient, it equals to -1. Okay, so an example, I'll do an example later. And same thing with this one, y equals to m. This m has to be the same as this m because they're parallel, but if they multiply with this gradient, okay, it has to equal to -1. That's what this is saying here. Okay, so it says two lines with gradients m1, m2. So if I gave you y equals to 2x, then the only way to have this being perpendicular is if the second one, y2, is equal to -half x. How do I know that? Because 2 times -half, so half of 2 is 1, and 1 times -1 is -1. This would make it perpendicular. So these two here, if we sketch on a calculator, it should be perpendicular. And I'll prove it to you. If we look at a calculator right now, we just go here. This was for my year 12, so don't worry about that. Look, if I typed in 2 times x, that's the line for 2x, true? Okay. But then if I did -half, so control -half times x, okay, so -half of x, it should be perpendicular. So have a look at that. See, it's right 90-degree angle with each other. Yeah, it's got that 90-degree cut there, so it's a 90-degree. Yeah, because -half times 2 makes it a perpendicular line. Yeah. All right. So now it's going back here. So we know if it's for it to be perpendicular, it has to times each other and gives you -1. So two things that you just picked up from year 9 again. Parallel, same gradient, different y-intercept. Perpendicular lines don't have the same gradient. They have gradients that multiply to equal -1. Okay. And the y-intercept doesn't matter. Okay. They might have the same y-intercept. But actually, it can't even have the same y-intercept. Actually, no, yes, it can have the same y-intercept. What am I talking about? Yes, it can have the same y-intercept. So the gradient has to multiply to -1. That's all you need to know. Okay. Let's do an example. Let's have a look at this one. Find the equation of a straight line which passes through 1, 2. So now I know there's a straight line, y equals mx plus c. So remember from the last exercise, y equals mx plus c passes through 1, 2. So when x is 1, y is 2. Now A, parallel to the line with equation 2x minus 4 2x minus y equals 4, okay? You want to find the equation of a straight line that is parallel. That's a key word. Now, what did we say before? We said parallel. If they are parallel, then this equation should have the same gradient. Okay. Now, what's this equation? Well, we've got 2x minus y equals 4. The problem with this one is I don't know what the equation is. Like, it's not in the form that we know. We don't have y equals mx plus c. Now, from the last exercise, remember I showed you, you want to rearrange this equation so you get y equals to mx plus c. Now, I know a lot of students would remove the 2x, minus 2x on both sides, and then divide it all by negative. You can do that. There's absolutely nothing wrong with that. I personally just like to add and subtract. So I can see here is a negative y. So for me, what I would do is I just say opposite of minus y is plus y. See, if I do that, minus y plus y cancels out to be 0. Then what I have now is I've got 2x equals to 4 plus y. And then, and I do that because I don't like negative y's, that's why. I don't like working with negatives. And this is a positive 4, so minus 4, minus 4. 4 minus 4 cancels out, and 2x minus 4, we don't know. We can't do that, so that's why it's 2x minus 4 is equal to y. There you go. So now I've got the same equation. It says y equals mx plus c. Clearly, this is my m, and this is my c. That equals to y. So I'm just rewriting it again. Y equals to 2x minus 4. So I know the gradient is 2. Y-intercept is negative 4. Okay. So what have I just done? Like, why did I rearrange it? Because the thing that we were looking for, and I'll highlight it here again, was it to be parallel. And it's parallel to this line. But we know that for it to be parallel, it has to have the same gradient. So the gradient right now is 2. Okay, so that means this new equation that I'm looking for, because that's what the question says. Find the equation of the straight line that passes through this and is parallel to that. So what I know now is in this new equation that I don't know yet, well, I just screwed up there. In this new equation, y equals to mx plus c. This is what I need to find. All they told me was this line will pass through 1, 2. I didn't know what the gradient was, but I did know it was parallel. So if it's parallel, that means they have to have the same gradient. So what they're saying here is they're saying that you have m equals 2. And you're back to exercise, I think it was 1C, equations of straight lines. You're back to 1C again. Okay, so now you've got a gradient and you've got a point. So if you've done 1C, you should be able to do this one. Same thing. So now you got y equals to 2x plus c. You know that it passes through when x is 1, y is 2. Okay, so when x is 1, y is 2. So 2 times 1 plus c, 2 plus c. Now c, if you want to remove that 2 there, this is a positive 2, so minus 2, minus 2. 2 minus 2 is 0. So therefore you now know c is 0. So your equation for the straight line, for it to be perpendicular to this, parallel to this, is y equals to, I've got my gradient 2x, and I found out c was 0. But you don't write plus 0, there's no point. You might as well just say 2x. There you go. And this is the rule. To test that rule, you said when x is 1, y is 2. So let's test that. If x equals 1, let's see if that's true. Y equals 2 times 1. Oh, hey, it does equal to 2. See? So that's true. That's how you know you've done it right. Okay, that's example 18. So that's the only part that you're really doing for A. So A was to find if it's parallel. And the only information I used was same gradient. I used that same gradient and I went back to exercise 2C to answer the question. Yeah, now I'm going to do do B, same thing, but now it's perpendicular. Okay, so now same thing, 2x minus 4, so it's now perpendicular. Okay, so I'm still trying to find this equation, but I know it's perpendicular. And the one thing we know is if it's perpendicular, they should multiply to -1. Now, just like before, we already solved for this. This is the same equation as before, so it ends up being y equals to, what was it again, 2x minus 4. Okay, that was the equation. And so for it to be perpendicular, remember this is now m equals 2, c equals -4. So if it's perpendicular, perpendicular, m1 times m2 has to equal to -1. Now you already got it. You got the first one. So 2m1, which is 2, what we don't know is m2. Okay? But we know that these two times to each other, so 2 times something has to equal to -1. Now this is kind of like algebra again. You know, if I didn't do a magic box and I said this was y, I said find y, what you would have done is, well, opposite of times 2 is divide 2. Divide 2. Yeah? Divide both sides by 2. So 2 divided by 2 is 1. And y would have equaled to 1 times y, which is y. And then negative half. Yeah, true. That's what you would have done. So what you figured out just now is m2 has to be negative half. Now that's nice because remember at the end of the day you were trying to find the equation of a straight line, which is y equals mx plus c. Now because you know it's perpendicular, you just figured out that, well, this m has to be negative half. So m2 has to be negative half. You got the point that it passes through 1, 2. So now same thing again. Going back to exercise 2C, you got y equals, you know the gradient has to be negative half for it to be perpendicular. You don't know what c is, but you do know when x is 1, y is 2. So here we go, we've got 2 equals negative half times 1 plus c. This gives you negative half plus c equals 2. And to find out c, we're now going to say add half on both sides. Negative half plus half cancels out, and 2 plus half, whoops, is 2.5 or 5 on 2. Yeah. I like to keep it in fractions because that's how you will be working in year 11 and 12. Don't change to decimals unless they ever ask. And the question doesn't say round to decimal places or anything like that. Leave it as fractions. So c is 5 on 2. So therefore your equation must then be y equals 2. Now that you got c and you got m, then the equation is pretty simple. It is just y equals 2, negative half x plus 5 on 2, because that's a positive 5 on 2. And you're done. Okay, so that's example 18 there. Parallel and perpendicular lines there. Okay, let's move to the next one. The coordinates of the vertices of a triangle ABC are, okay, now you can draw this if you want, but they want you to show that the side AB is perpendicular to the side AC. Now if I were to draw this just to help you visualize this, okay, oops, help you visualize this, let's do, it goes up to about 3. Okay, so let's say 1, 2, 3, negative 1, negative 2, negative 3. You don't have to draw this. I'm just doing it to teach you. Okay, negative 1, negative 2, 3. Okay, so these are the points we have. Let's go with the points. We got 0, negative 1. So A is at 0, negative 1. So 0, negative 1 is here. So this is A. Then you got 2, 3. So 2, 3. This is B. Oops, I should just write B. Okay. And then you got C, which is 3, negative 2.5. So 2.5 is about here. Negative 3, 2.5. C. So you got this triangle, ABC. Okay. Now apparently, AB is perpendicular to AC. So what they're trying to say is, this is perpendicular. It's right angle. So yeah, this is AB. This is AC, and it should make a 90-degree angle. Okay. So the only way to prove that is you need to first find the line, the equation of the line AB. You need to know what the equation of line AB is. So this one has to be some sort of y equals mx plus c, which I'll call that m1 and y1. Okay, and then this is also another equation from A to C is another equation where it's again y equals to m2x plus c. Okay, so you got two equations to figure out. You got the coordinates. Now this goes all the way back to exercise 2B and 2C. So you can find the equation of a line with 2 points. Okay, so the first thing we want to find is A, B. Okay, the equation of a line. Now, equation of a line is y equals mx plus c. We need a gradient and we need a y-intercept. Now, we've got 2 points. We've got A and we've got B. Yeah, so A was at 0, negative 1, and B was at 2, 3. Now, from exercise 2B, remember to find out the gradient between, and you have 2 points, you can use y2 minus y1, x2 minus x1, yeah? So rise over run, y2 minus y1 over x2 minus x1. So if I'm going to solve for the gradient, because that's what I need the m here, then 0, negative 1, this is my y value, so I can do negative 1 minus 3 if I wanted to, so negative 1 minus 3. And then my x value, 0 take away 2, 0 take away 2, yeah? And that simplifies down to negative 4 over negative 2, which gives you positive 2. True? Okay, so that tells me now the gradient is 2. That's what I just figured out. I now know y equals to 2x plus c. I don't know what c is, and the only way to find out is I need a point. Now, they've already given you a point. You've got either 0, -1, or you got 2 and 3, because that's the points on A, B. So you choose any one of them. I'd probably choose A because it's the easiest one. There's 0 and then there's a -1. So substitute 0, -1 to solve for C. So that's what I'm going to do. X is 0 and y is -1. So it becomes -1 equals to 2 times 0 plus C. And that becomes 0 plus C. Therefore, C equals to -1. Okay, or if you like it, it will be -1 equals C. Same thing. So I already figured out the first equation. AB, the equation of AB has to be y equals the gradient, which we found out was 2. And we just found out C was -1. Whoops, -1. There we go. Okay, so we've found the equation of AB. Now we need to find out the equation of AC. Okay, gradient of AC. Technically, you don't need to find the equation. I'm just doing it all in one go so you can see. Now to find AC, again, you've got AC. So AC, actually I should do it in red so you can see the color coding. AC, we now need to know y equals mx plus c for this one as well. Now AC, the only way to do that is you find the gradient. Now we've got A, which is 0, -1. And we've got C, which is 3, -2.5. Okay, I don't like writing mixed fractions, so I'll do 3. That's -4 plus 1, -3, -5, -5 on 2. Okay, -5 on 2. So there we go. We've got our improper fraction there. So now, same thing. I've got my C. Okay, I've got my C. I've got my A. Now, same thing. To find out M, which is the gradient, you need to use y2 minus y1, so m equals y2 minus y1 over x2 minus x1. Okay, so looking at this, you've got -1. You can do -1 minus 5 on 2, and you can go 0 minus 3 if you want. You know, so I'm just doing y2 minus y1, x2 minus x1. Yeah, doesn't matter which one you do. You can do either one. Like you can do -5 on 2, take away -1, and 3 take away 0 if you wanted. Doesn't matter. Same answers. So there we go. We got -1 minus -5 on 2. Okay, I'm using brackets so I don't make a mistake there. So -1 minus 5 on 2. The y's were the y's. And then now I'm doing the x coordinates. So the x coordinates 0 minus 3. 0 minus 3. Now this gives me -1. 2 negatives make a positive. So plus 5 on 2. And this is over -3. Now I know a lot of students don't like this fraction, but you're going to work with it. You have to learn how to use fractions. You can't keep avoiding them. So -1 plus 5 on 2. That's the same thing as writing -2 on 2. Because, you know, 1 is the same thing as writing 2 divided by 2. Plus 5 on 2 on -3. Now, -2, now denominator is the same. So -2 plus 5 is -3. I mean, not 3, just 3. 3 on 2, okay, divided by -3. Okay, and then from here, see, this is not hard, by the way. The technique is not hard. It's just fractions. A lot of us, we don't like fractions. So 3 over 2, this means divide. So this means divide here. So 3 over 2 divide -3, which is the same thing as writing 3 over 2 times -1 on 3, which now works out to be -half. Okay, because you can cross simplify from year 8 and year 9. Cross simplify, 3 divided by 3 is 1. So 1 times -1 is -1. 2 times 1 is 2. Yeah? Alright, so after doing all those algebra, all I just found out was m. Because remember, don't lose track of what you were trying to find. You were trying to find the gradient, m. So m is -half. So here we now just found y equals to -half times x plus c. I don't know what plus c is. But the only way to find out, the only technique I've shown you, I'm just going to rub all this off here because I need more space to write. The only technique, so I'm just revising exercise 2C? Yeah, 2C, find the equation of a line. I've got y equals -half x plus c. In order to find c, I need a coordinate. And I already got a coordinate. I've got either 0 or -1 or 3, -5 and 2. Doesn't matter which one you choose. Yeah, I'd probably choose A because it's got a 0 and -1. So sub 0, negative 1 in, and now you got negative 1 is equal to negative half times 0 plus c, and this now gives me 0 plus c, negative 1, so c equals to negative 1. Okay, and so there you go. So this now gives me, therefore, the equation. You got negative c, and you got the equation of m, which is negative half, so your equation is y equals to negative half of x minus 1. Whoops. Okay, so now you got these two equations. This is your AC, and this was AB. But you haven't finished. The question says, show that the side AB, which is the first equation, is perpendicular to side AC. Now, remember, the only way for them to be perpendicular is if their gradients times each other to give you negative 1. But they do, because you got y equals 2. See, this one has a gradient of 2. M1 has a gradient of 2. And then this one has a gradient of negative half. So let's test it. It's only perpendicular if you multiply them, so let's test it. M1 was 2 times, this is negative half, equals 2, and 2 times negative half, or half of 2 is 1, 1 times negative 1 is negative 1. So yeah, therefore, AB and AC are perpendicular. Okay, that's how you do that example there. Alright, so you can see you're really just playing around with parallel and perpendicular lines. There was only two properties that you had to learn. Parallel means same gradient, different y-intercept, or you can have the same y-intercept, but then it's the same line. And then perpendicular lines, m1 times m2 equals negative 1. That's all you're doing. Okay, so if you look at the examples here, the exercises, they say find the equation of a straight line. It passes through this point. This is my first example. Parallel, perpendicular, parallel, perpendicular, parallel, perpendicular. Yeah? This one means that gradient is 2. This one means that the gradient has to multiply to each other to give you negative 1. So the second one has to be negative half. 2 times negative half gives you negative 1. Yeah? And then you're just working with exercise 2C again. You're just doing 2C in this one. It's just worded differently. Parallel, perpendicular. Parallel, perpendicular. That's it. Okay? For which of the following pairs of equations corresponding lines parallel to each other? So you have to rearrange these ones now. So this one is, this has a gradient of 3. So as long as this has a gradient of 3, so you've got to rearrange it, check if it has a gradient of 3, rearrange it so that it's in the form y equals mx plus c. Okay, meaning that, so I'll just do the first one there in case you don't understand what I mean. So here you've got 2y equals to 6x plus 4. You're not used to that. You're used to if it was just y. Now the only way to get y is you divide this by 2 and divide all of this by 2. See, 2 divided by 2 is 1. And why did you divide? Because 2y means 2 times y. That's why you divide both sides by 2. Yeah? So now you got 1y on the left-hand side. On the right-hand side, 6 divided by 2 is 3x. But then 4 divided by 2 is also 2. Remember, you can split this fraction up into 6x over 2 plus 4 over 2. That's why I divided 2 on both of them. Okay, it's not just 6 divided by 2, it's also 4 divided by 2, because it's all divided by 2. Yeah, and that, now if you look at this, this has a gradient of 3. This has a gradient of 3, but this has a y-intercept of 4, and this has a y-intercept of 2. Yes. These are parallel. So this are. And then you do the same for the, this one, rearrange that, rearrange this, rearrange that, rearrange. Yeah? So that's 1 and 2. 3, find the equation of a line perpendicular to the line x equals 3. So x equals 3, remember that's a vertical line from exercise 2D. So x equals 3. Perpendicular to it means just horizontal. So for it to be parallel, as long as it's just a horizontal line. So it could be y equals 1, it could be y equals 2. All this is parallel, perpendicular to it. Okay, but you want it to pass through 3, 4. So if it passes through 3, 4, 3, 4 is over here. So that means the only way for it to be perpendicular is if the second line was y equals 4. That's the only one that crosses, is a horizontal line, and it crosses 3, 4. Okay, so that's the answer for this one. We're just saying the answer has to be y equals 4. Yeah, and vice versa. If the line is y equals 3, it's a horizontal line, you need it to be vertical. And it needs to pass through this point. You know, so that means x has to be 2. X equals 2. Alright, find the equation of a straight line passes through the point, so it goes through a point and is perpendicular. So you just need to make sure negative half times something equals negative 1, and you get the gradient. Once you got the gradient, you got a point, you can find out c, and you get the equation. So that's all the same as exercise 2C. Same thing with this one. This is the same as the last example as I did. Same example as what the one I did before. And same example as the last one I did. Okay, and that concludes exercise 2E. Yeah, all of these are the same thing as well. Okay, same thing. All right, I think that's it. Yeah, that's about it. Cool. So main thing from exercise 2E, perpendicular, parallel. Parallel means the same gradient. Perpendicular means the two gradients multiply to each other, give you negative 1. So I'll just go back to that property. Okay, so it's this one. Whoops. Oh, whoops. It is this one here. Okay, that's perpendicular. And parallel is this one here. Same gradient. There's only two, and you're using all the skills you've learnt prior to this to solve the problem. Okay, fantastic. Those are your 3 videos that I'm going to be uploading now. I'm going to stop this video. So that should cover you for Monday, Tuesday, Wednesday, and I'll see you back on a Thursday. Okay, and I'll be checking you with a quiz. I'll come back with a quiz and I'll check what you know, what you don't know. So if you haven't done any work, I will know. If you watch this video or not, I will also know, because you wouldn't hear this message. Okay. All right, here we go. I'm going to stop.